Okay, let's start. Hello, guys. I hope you are not surprised by English. So, thank you for joining this presentation. I will try not to take too much time because I know that the guys before me take too much time, like 1 hour and 10 minutes. So, a little bit about me. My name is Haidar. I'm a member of Industrial Security Service Team in Kaspersky. I'm a security researcher, public speaker. I do mainly Windows researches. And in our team, we analyze systems. So we should have many skills, starting from penetration testing to reverse engineering, network, radio, ACS, and many more. So if just one of you interested in or like good in one of these fields and want to expand the expertise to another fields, please like connect with me. Maybe we'll be like in the same team. So here, QR code, you can check my page. It does contain my talks, my researches, tools, unique techniques, and many more. So what's this talk about? Today I will share with you a step-by-step security assessment that I conducted to one of our customers over 6 months. It was a special ZigBee implementation because they was using something we call non-public ZigBee profile, which you will face a lot in industrial environment. So for this reason, all the usual tools and framework didn't work. So I had to re-implement a lot of things that I will share with you today. So in this presentation, in the beginning, I will start a little bit talking about ZigBee foundations, and after that, we will go immediately to the project to see like the problem that I faced, how I solve it, and the technical details under it. So what is ZigBee? ZigBee is like wireless communication protocol, exactly like Wi-Fi, but it has its own stack. And it's used in some networks we call WSN, or wireless sensors networks. The main goal for ZigBee is like to maintain power, and it's based on IEEE 802.15.4 standard. The main applications for ZigBee is like to conduct the low data rate applications and for short range communications. Also, ZigBee operates in 2.4 gigahertz frequencies, sharing it with the Bluetooth and Wi-Fi. You can see the ZigBee in your smart homes, like if you have Elisa, for example, or Alexa connected to some sensors. So they most likely they're using ZigBee, and also you see it a lot in industrial automation or industrial in general. We said like it's wireless communication protocol. Why we are using ZigBee instead of Wi-Fi in WSN or in wireless sensors networks? First, in WSN may usually contain a lot of sensors. And the sensors, it has a batteries that it takes 1 year to change it, or maybe in some environment you couldn't even change it. So the power consumption is very critical, and they developed the ZigBee in order to achieve this thing by power consumption. Also, the ZigBee or the WSN, most likely it used with thousands of sensors for example, to just coverage like large space. So for this reason, ZigBee it will be suitable because it can coverage like thousands of nodes, unlike Wi-Fi. That's I think it's like 100 node at most. Also, the WSN need like very low data rate applications, and so the ZigBee is suitable, not like Wi-Fi that it used in like high data rate applications like video streaming. So people get confused between ZigBee and .15.4. What is the difference? ZigBee, it's a stack, okay? But like inside it, .15.4 IEEE defined the first two layers, the physic and the MAC. And for the ZigBee, it defined the network and application. So the network, they have like its own routing protocol like AODV, and it defines its own profiles in the application. And for this first two layer is .15.4 that defines the modulation and the access to the channel. Also, not only ZigBee operates over .15.4, but we have another protocols like Thread, MIUI, 6WPAN, and many more. So here's the wireless band. I said like it operates in 2.4 gigahertz. Also, actually, there's another frequency band. We will concentrate today on 2.4. The ZigBee share it with the Bluetooth and Wi-Fi, as you can see in the photo. And we have 16 channels from 11 to 26. Each channel bandwidth is 2 megahertz, and we have a gap 5 megahertz between these channels. Now, ZigBee devices. We have 3 types of devices. We have something we call ZigBee coordinator, which acts as the brain of the network, the main node in the network. It starts the network, manages all the aspects of the network and communication. It also, the most interesting thing, that it accepts childs. We have a ZigBee router that acts as a usual router, like for forwarding data, and used for extend the network, and also it accepts childs. And we have ZigBee end devices, which we called it most likely sensors, even if it's not sensors. Maybe it's like buttons, relays, remotes. But just the name is sensors. And here, actually, where the power consumption happened, these devices go to sleep in most cases. And like to save power, and it didn't accept any child, so it's just the end device. Now, in ZigBee networks, as I said, like the ZigBee coordinator, the brain of the network, it starts the network, and it always have an address. We'll come to addresses later, like 4 zeros. And also it selects the channel, because we said we have from 11 to 26. So, and ZigBee, not like a Bluetooth, it uses only one frequency for communication for all the nodes. So it chooses the channel. After that, it chooses some unique identifier with 2 bytes called PAN ID, a just number for this network. Also, it chooses extended PAN ID, which is ASCII representation for the name of the network, just any name like SSID in Wi-Fi. Now, for addresses in ZigBee, we have 2 types. First one, we call it short address with 2 bytes. We can imagine it as an IP. And we have another one is called extended address, which is MAC address, but with 8 bytes. Not like 6, as like TCP IP. The POS addresses is used in 2 layers, not like TCP IP. TCP IP, you can use IP, for example, in the 3rd layer, and you can use MAC in the 2nd. But in ZigBee, the both addresses can be used in both layers. Now, to go to the one customer came to us, and he said, like, I have this ZigBee set. I have a ZigBee coordinator that's connected with endpoint through ZigBee, of course, and this endpoint is connected to relay. And the customer was able to toggle the state of the relay using ZigBee communication. The coordinator had multiple interfaces like Wi-Fi, Bluetooth, LTE, and many more. Our goal is to hijack the communication between the coordinator and the endpoint, inject some ZigBee packets, and take control of the relay, to turn it off and turn it on. How we can imagine it? You can imagine it as a smart home setup. You have like Elisa connected with smart relay. That's inside it. There is endpoint and relay. And you tell Elisa with the voice interface, like to turn on and turn off the light, for example. And what's actually happened is just ZigBee packet fly from Elisa to this smart relay. Also with Wi-Fi interface with Elisa, you can control the lights from your phone. In industrial environment, how we can imagine it, it's just like you have a PC for the operators that's connected to the ZigBee coordinator through Wi-Fi, and the ZigBee coordinator connected to the endpoint, or actually it will be like multiple or thousands of endpoints, and each endpoint connected to the relay. Operator or some other triggers can turn off or turn on the relay. Now, for our strategy, as any radio assessment, first you need to start to sniff the traffic. How you can do it in ZigBee? Very easy. You just need to buy this dongle from Nordic. It's called an RF52840. It's very cheap. There is special firmware. You can flash it, use Wireshark, and you can start sniffing. But before you sniffing, you should choose the channel, because we said we have from 11 to 26. How you can choose the channel? Easy. Just change the channels, like one by one, until you get to that channel with traffic. In our case, we determine the channel, and we say some packets in the photo above, but it was encrypted in the network level. But we were able to extract a little bit of data, like as you can see, the source, which was the coordinator, the PAN ID. Also, we extracted some MAC addresses that was very helpful. Now, after we get the traffic, it's encrypted. We need to understand it, what they exchange. To decrypt it, I should tell you first about how the decryption done inside ZigBee. In ZigBee, we have something we called network key, which actually was our traffic was decrypted by And the network key is a symmetric encryption key shared between all ZigBee nodes, and it ensures encryption on the network level, and not only encryption, actually integrity also. And it's most likely randomly generated and delivered from coordinator to the endpoint device or to the router through a packet called transferred key packet. You see it in Wireshark transferred key packet, but actually it's transferred the key because it contains the network key encrypted with another key called link key. What is link key? Is a key for authentication. If the node has this key, meaning it can connect to this network. And it's used for delivering the network key, also symmetric with symmetric encryption. How they install this key? Maybe by hard-coded only, or it can be done by some exchange algorithms, but most likely it's hard-coded. And also, most likely is a default key called ZigBee alias link key. We will come to that later, why they use this default key, and its value just like this string ZigBee alias 09. So now, how we can decrypt? Actually, you have two choices here. If you control the network, you can disconnect the devices from each other and connect it again. While you connect, you sniff the traffic. And but this stage, it needs you the network key. Like you can try the default one, ZigBee alias, and after that, you can decrypt transferred key packet. You get the network key, and you decrypt the communication. Now, if you are not able to do the first step, only one way is to guess the network key, but it's, as I said, most likely it's randomly generated. How we can obtain the keys itself? First, you need to try the default keys. In the level of the link key, it can be, as I said, like default, ZigBee alias 09, which is default in the all manufacturers, not only the, I mean, all the manufacturers, most likely they use ZigBee alias 09. You cannot try default network key at this level because there's no default network key in the level of the manufacturers overall. So you try this link key, maybe you are lucky, and if it's default. The second step, if your first step didn't had any success, so you identify the manufacturer. How you can do that? By the MAC address that you obtain from the traffic, or by, if you have physical access to the device, by looking at the chip, you get the manufacturer. After that, you look inside like search engines for the default link and network keys, and maybe also you are lucky to find it. If nothing like happened with these three stages, you have only one option: to extract the firmware and reverse it, and search for the keys inside it. What we did in our case actually, we were able to obtain it through default, because I told you, like, we get the MAC addresses by search for the manufacturer. We found some default keys. We were able to obtain it. Also, we tried to expand the attack surface, finding more attack vectors. So we extract also the firmware and obtain the network key. After we obtain the network key, we put it in Wireshark. It's very straightforward, and we get the traffic and encrypted, as you can see, like this is ZCL. Now we decrypt the traffic. We need now to inject some packet in the ZigBee communication in order to hijack this relay. To do that, we need to choose our hardware. We have actually at that time two options: CC2531 USB dongle, which is very cheap also, and also we have option with looking with SDR, like Blade RF. We start with FDR, but because it's like more flexible, but the implementation inside GNU Radio had problems, so we moved to this dongle, and this dongle support one firmware that allow it to work with some framework called Killer Bee for ZigBee, and from this framework there is some libraries that allow you to inject raw ZigBee packets. That's what we need. How you can flash it? Using Raspberry Pi or using special hardware called CC debugger. So we have our injector. We have the key that we can decrypt and encrypt. So now is time to craft the packet that we need to send in order to turn off or turn on. But first, to understand what this packet should look like. So by opening Wireshark, you can know, but when we open Wireshark, we see, as you can say, like in the red, Manford packet, meaning Wireshark couldn't intercept this packet successfully for some reason, like maybe some bytes missing, some header mismatching, something like this. And to know the reason, we should talk about the application layer in ZigBee. ZigBee used profiles. Like a Bluetooth. What is a profiles? It's just agreement between the manufacturers to work with each other. For example, you have Elisa in your home from Yandex, and you want to both, I don't know, sensor from Xiaomi, for example. And both of them belong to different manufacturers. How they can understand each other, like connect to each other, like work the application, they need these profiles that they have agreement about. These profiles, in our case, like between Xiaomi and Yandex, called public. And maybe, for example, Yandex develop its own profiles that only devices from Yandex can communicate with each other. We called it private in this case, or maybe it is published that was public, that was private and now public. Also in ZigBee, we have endpoints that represent the applications, that represent the functionality. So one device can have multiple endpoints, each endpoint point for specific functionality, like one for light control, another for temperature sensing, and inside this endpoint, they run the profile. We have some special endpoints like 0 for like device management and 255 just for broadcast to all endpoints. So inside the endpoint, we have clusters. And the cluster is just tell the endpoint what I want to do. Like I want to turn on the light, or I just want to read the state of the light. So we have commands and we have attributes. And how they extract this cluster using some library called ZCL, that just how the bytes should be ordered for specific commands or for specific attributes. Here in the photo, for example, to the left, you can see it from Wireshark for application home automation like smart homes, and you see that we are using the first endpoint to turn off like the relay, which defined using ZCL with command like off with 0, 2 zeros. And to the right is just like how we can manage the device using profile device, ZigBee device profile. Now, in our case, our customer was using private profile in the level of the manufacturer. And all of things that I mentioned about public profile, it didn't work here. So what we had to do, we had to develop our algorithms. That's first, we sniff the traffic. We turn the relay off and on using Wi-Fi. And after that, decrypt it because we have the network key. Extract the application payload, do reverse engineering on the level of communication, knows how the bytes order like to turn off or turn on the relay. In active phase, we craft the same ZigBee packets that we get from reverse engineering. We encrypt it with the network key that we have. We inject it with our debugger. How we craft the packet for ZigBee, it's easy, like SCAPI network library. It provides you some libraries for or submodules for .15.4 and for ZigBee itself. So you can build your packet just by putting the headers and the values inside it. And using Killer B, as you can see, you can inject it to specific channel. Also, you can do encryption. It's very easy. Now, I injected it at that time, but it didn't work. Why? It seems that in ZigBee, they have something called prevention against reply attack. So inside the ZigBee security header, there is a frame counter. And this frame counter should be increased by 1 by each packet sent by the coordinator. So when the endpoint received it, it will check if it's increased or not. If it's not, meaning this frame is like replied from some illegitimate node. So now in our case, we should extend. The passive mode will still the same. But in active, we will start by sniffing the traffic till we found, and decrypt it, of course, until we found can coordinator send some valid packet to the endpoint. We extract the frame counter, and actually also our customer was using some counters on the application level. We should increase all the counters, also craft a packets, encrypt it with network key, and inject it with this CC2531. We successfully like manipulate the relay, everything was good, but still this dongle was not efficient enough. Sometimes it works, another not, so we start searching about like cheap alternative, not complicated. And we found inside the OS, or like RTOS, real-time operating system, run under this like NRF dongle that we used for sniffing traffic. They use some radio API that allow you to inject raw ZigBee packets. So we use this API, we use Python for serial communication, and we was able to send raw packets. At that time, we had like 1 week left. For our assessment. Also, we tried to expand our attack surface. So we came with an attack vector, like what if I can mimic or spoof the original coordinator, make the node connected to me, and I take control for this endpoint at O. How to do that? First, we need this endpoint to leave the old coordinator and make it connected to me instead. For leaving, actually, you will get surprised, it's very easy in ZigBee. There is some property in ZigBee that said, like, if two coordinators operate in the same channel, and one coordinator receive a beacon with the same PAN ID that this coordinator operates on, the coordinator should ask all the nodes to leave the network. Because like there is PAN ID conflict and they operate on the same channel, so there will be collision. So what I did, I just craft a beacon with the same PAN ID. And as you can see the photo to the right, the coordinator with 4 zeros received it, and after that it said, oh, there is PAN identifier, and the endpoint start to leave. Now it's time to make it choose me. But before to choose me, let's talk about something we called beaconing in ZigBee. In ZigBee, there is 2 types of networks, like beacon-enabled networks and non-beacon-enabled networks. In beacon-enabled networks, they use some frame to know the endpoints where it should send some data and where it should not, and where it doesn't send data, it goes to sleep for just power consumption. In our case, we are using non-beacon-enabled networks, but still we use beacon frame just for information about the networks. The kind of information the node can get is like the PAN ID, the extended PAN ID, and many more. But how the node will join, we said like we have 26 channels, so it will start to send beacon request in every channel, and it will wait until receive beacon response. And when it will receive this beacon response, it will check the extend PAN ID. If it's match, it's like a criteria, for example, the name of the network, it will just connect. Inside the beacon, there is a field called update ID, which indicates that if it's increased from the previous frame, it will indicate that the coordinator have some new information about the network, some updates. So I came with an idea. Like, I mean, in general in ZigBee, the behavior when you have 2 coordinators operate with the same extend PAN ID, so the behavior is not defined which one the node will or the endpoint will choose. Like actually, I did it every time it was choosing the old coordinator. So I decided like if I increased the update ID to 2, telling this node, oh, I have like more information or more update information than this coordinator. Maybe it will choose me. And actually, it chose me. I make it connected to me. But after I make it choose me, there was some problems because I should answer very fast to this packet that sent. We will tell about it later. And that's impossible by the Python because remember, I'm generating bytes through Python and send it over serial communication to the dongle. Also, auto acknowledgement should be enabled, which also impossible for using Python. But at that time, actually, like we stopped our activities because we had the deadline. After a couple of months, the customer came back with a new setup. He said like, okay, this is the endpoint and this is the relay and do your job. And this time customer didn't provide us with the coordinator itself, which was like crazy. So first I started with reconnaissance. So I want to check like what this endpoint operate on. After I determined the channel, I saw it still connected to the old network. In ZigBee, there is something interesting that even if you turn off the node or turn off the coordinator, the endpoint will still connected to the coordinator, not like Wi-Fi, for example. It seems like still connected, but they use the same network key, so I was able to decrypt, and I was able to get some values like the PAN ID and other, but still I need some very interesting one with the extend PAN ID, because I want to use it to spoof a coordinator. How to do that? It seems this node act as a router, and Zigbee, the nodes that act as a router, can do beaconing also. So I sent beacon request, it sent me beacon response, and inside it, I found the extended PAN ID. So now it's time to make it leave the old network. How to do that? We have the network key, right? We can just spoof some commands and said, okay, leave the network. But remember about the frame counter that we talked about before. The frame counter, it's just hard-coded or not hard-coded. It's just like inside the endpoint. And I should know the frame counter of the old coordinator, but I don't have the old coordinator. So maybe I can guess it, but still I think it's like 4 bytes. It's impossible to guess. You can use a high value, but most likely in many manufacturers that doesn't work. So I should came also with something. I started reading the documentation, and I found, for Zigbee, I mean the specification, and I found interesting behavior. They said, if the node detects some other node in the network that use the same short address, meaning there is a conflict in addressing, because it's like 2 bytes and most likely will be the same, so the node should immediately leave the network. So what I did, I just created a random packet with the same address of the, or short address of the endpoint. I encrypted with the network key, and I put random frame counter. And when it's just received it, it get panicked and leave the network. Why is this behavior? I think for this manufacturer, they check the network address before they check the frame counter. So I was successfully like, I make it leave. Now it's time, after it leaves, now I should spoof the coordinator and make it connected to me. So now we will return to our problems. First one, I should answer very fast from Python. Second one, I should implement the auto acknowledgement, which is impossible to be done. I mean, can you imagine, like now you are not only rebuilding the Zigbee, you are rebuilding also the .15.4. You are rebuilding whole protocol or like specification. So I came with an idea why I should reinvented the wheel. I can use this dongle from Nordic NRF. Because this dongle originally used for doing Zigbee stuff. So I can just flush it with coordinator framework, set the exact extend PAN ID, and make the node connected to me. But it seems like it answered very fast. Okay, everything is working, but still the node, it didn't choose this coordinator. At that time, I wondered why. Like I check or I compare the beaconing from the old coordinator and with this Nordic coordinator, and inside it I found something called stack profile. And this stack profile tells the node which profile this coordinator used. In general, like it used public profiles, but remember, like we said, our customer was using private profile. The value for it is 0, and for the public profile, the value is Zigbee Pro like 2. So it seems that I need to change this value inside the Nordic dongle, but it seems there's no way to change it. I even connected with Nordic. I did reverse engineering on the firmware, but no way. So it seems I should reinvent the wheel. So first, I concentrate on auto acknowledgement. And when I get deeper inside this RTOS, Ziffer1, I found that you can set a coordinator for .15.4 level, meaning for the first and the second layer, actually specifically for the second layer. So you tell this node, okay, act as a coordinator. This is your PAN ID. This is your extend, or not extend. This is PAN ID. This is your address, and only received network packets that belong to these addresses, which it was wrong in our like old implementation, because we were like operating in promiscuous mode. We received all the packets and we analyzed it in Python. So now, in our new implementation, we have Mac and Physic that enable us to do auto-acknowledgement from the dongle itself because it already acts as a coordinator in this level. And for the Zigbee, we can do it in Python. I started coding in Zigbee like it was 1,000 page because remember Scapy allow you to to craft the headers but not the logic of like initiating the communication or doing like encryption or other stuff. So I start coding, but still I faced the problem that I should answer fast. Also, it was like very hard with Python. So I came with like simple idea. Let me generate the bytes before. After that, I hard-coded on the dongle, and with just with some if statement, if you receive these bytes, meaning you should send these bytes. And it was work, and I was like answering very fast, and I was able with auto-acknowledgement. But still, I had one problem. So let's talk about connection initiating in Zigbee. As I said before, the Zigbee endpoint will send beacon request in every channel, and it will wait for beacon response. It checks the beacon response. If it has the specific extended ID, it will choose this network. After that, the node should send, okay, I want to connect to you by association request. The coordinator should send acknowledgement. After that, the node should send, okay, give me a network address. The coordinator will respond with the network address, and immediately after that, the coordinator will send transport key packet, which is encrypted with the link key and which will deliver the network key to this node. If the node have the correct link key, the authentication key will decrypt this packet, get the network key, and use it for encrypting another packet called device announcement. And it will send it. If the coordinator was able to decrypt it, meaning the node has the same, meaning the node has already get the correct network key, and meaning it's authenticated. But what I faced when I enabled the communication initiating, I faced that this transport key packet, it used some special algorithm for encryption. I mean, the encryption level almost the same, but the key should be hashed before it used, and it was disaster. Like I spent 3 days, me and ChatGPT, just to do it in Python. Like there's only one implementation, it was in Wireshark, and it was in C. So I re-implemented in Python, everything is okay, and the node finally connected to me, and we start we can say start to a little bit communicate with each other. But I sent the same packet from the first stage of our assessment, but the relay didn't answer me. And I don't have the coordinator to know what's happening. So we had to reverse the firmware, and we just knew that the customer upgrades the security of the relay. So now you should exchange a lot of values with the coordinator, which we don't have. And after that, or with the endpoint actually. And after that, you build your exploit. But it seems like I sent some command to this endpoint. I knew from the logs that this endpoint received my packets, but it didn't reply to me. At that time, I didn't know why. Why every time I send, it receive it, but like I said, give me your, for example, MAC address, but it just like ignore it. So I said maybe the problem because I need to implement routing algorithms here. In Zigbee, there is some packet called link status that is exchanged by the nodes, telling that, oh, this is my routing table, add it to yours, so we can communicate, you know, like how to communicate to me. So I said maybe like I missed this part from my Zigbee implementation, so let's do it. And this packet, it's also encrypted with network key, so I should do it in Python, and I should increase the frame counters, and I should do the stuff. And also I spent like a couple of days doing that. I implement the routing, but still it didn't answer me. After a lot of digging, I found this thing that and the mic, it didn't work, okay. In Zigbee, we have something we call sync, and the sync is act as a server. So it's the server on the coordinator, and all the clients, the endpoint, should send the information to this sync. And it seems our customer will not respond to the sync, which is us, until I said, hey, I exist. So we should send some packet to the endpoint, tell, look, I'm your sync, answer me, please. So I implement that, I send it, and finally, I was able like to get control for all the end device. So some takeaways, always starting with default keys will like it's very easy solution and very valuable. After that, start to do, which is like actually gold rule from reverse engineering. Always check before you start the job if someone did this job for you before. So also it will save time. Also think out of the box, like don't follow like steps one by one, just think about, you can play with headers, with values, with everything. Also fuzzing will be helpful, and also don't rely on automated frameworks because most likely will give you like false results. So thank you for listening. Here's my Twitter and also our channel Purple Shift. You can find more information about that. Thank you.